In this video we're going to look at quadratic graphs and seeing if we can recognise the equation from the graph, but these ones are going to be in completed square form. A graph is in, or an equation is in completed square form if it is in the form y equals x plus a squared plus b. For example, it could be y equals x plus 3 squared plus 2, y equals x minus 4 squared minus 6, and so on. So these values of a and b could be any number. And what we're going to look at is the graphs of these parabolas and how we can identify how to put them into this form, and if they are in this form, how could we draw them? Okay, here we've got our regular y equals x squared parabola. Okay, notice that it's got a turning point at 0, 0. Its line of symmetry is the y-axis. It's a happy parabola. It's got a smiley face. And if we think back to the previous video on movement vertically, this graph here is the graph of y equals x squared take away 6. So when we've got this constant attached onto the end, we simply just shift it down 6. Or if it was y equals x squared plus 2, we would shift it up 2. So this constant here determines if the graph moves up the way or if it moves down the way. But if we compare this to, for example, y equals x minus 6 squared, we're going to see that this graph and y equals x minus 6 all squared are drastically different. Okay, so here we've got the regular y equals x squared parabola, the graph of y equals x squared. And if we compare it to the previous slide, y equals x squared minus 6 came down about here. But if we put it in a bracket and have y equals x take 6 all squared, our graph actually shifts to the right 6 places. And we could obtain this by doing a table of values, for example. So when I've got x take 6 inside a bracket, it moves 6 places to the right. Let's see what happens if I've got y equals x plus 7 squared, for example. Okay, this time we've got the graph on the left hand side, y equals x squared x plus 7 squared. So notice this time, despite the fact that we're adding 7 inside the bracket, it's moving to the left. So it kind of does the opposite to what you think. So the turning point here would be minus 7, 0. Here it would be 6, 0. Something to think about as we move on. Okay, here we've got a slightly different graph. We've got y equals x plus 3 all squared, then plus 2. Remember, if we think back to the previous video, where we had, say, y equals x squared plus 2, that would shift our parabola up 2 places. Let's have a look at what's happened here to this parabola, to this graph. So our usual parabola, y equals x squared, is symmetrical around this axis here, and its turning point is 0, 0. But this time we see that the turning point of this one is up 2 places. So basically the same rules apply. If we're adding on 2, our parabola is going to move 2 up the way. If this was x plus 3 squared, take away 9, it would be down here somewhere. So the part at the end does the same function. The constant at the end either moves it vertically up or down. Inside the bracket we've got x plus 3 squared. So remember, this does the opposite to what you think. You would probably think that we should move 3 to the right, but actually we move 3 to the left. So this time our turning point is minus 3 2. And that corresponds to the negative of this value and this value at the end. Let's try another example without the graph being given to us. Okay, let's imagine we were given this parabola here, this graph here, and we had to write down the equation of this parabola. So it was always going to be in the form y equals, and it's going to be in the form with a bracket squared. The first thing that I would recommend doing is trying to put on this constant part at the end. Okay, because that would determine if we've moved up or if we've moved down. Here we have clearly moved down. We have moved down 1, 2, 3. So at the end, we can take away 3. What else can we look at? Let's look at the nature of the parabola in terms of, is it a happy parabola or a sad parabola? We can see it's got like a sad face, so that means that it's going to be negative. We're going to have x, and let's have a look. We have moved to the right 6. So if we move to the right, we're actually taking away 6. If we move to the left 6, it would be plus 6. Okay, so the main points in this video are that if this term is negative, we move to the right, and if the term is positive, we would move to the left. The constant at the end performs the same function. It would move us down 3, or it could move us up 3, depending on the constant at the end.